In college algebra, we wrapped up graphing rational functions. So we were on the very last problem, and we're going to take it one step at a time. Step one is y-intercept, and that's where you plug in 0. And you end up with 0 up top and a -4 on the bottom, which is just 0. So make a dot on the origin. Next is step 2, and that is the x-intercept. You set the numerator equal to 0 and solve. That one comes out pretty easy as well. You divide both sides by 3, and you get 0 again. And we already have a dot there. Let's move on to vertical asymptotes. So this is where you set the denominator equal to 0. Sometimes you have to factor, like this situation, but that's pretty easy. We've done this one a million times. X plus 2, x minus 2, which means you have a vertical asymptote at -2 and 2. So find those spots on the x-axis and draw a dashed line. All right, horizontal asymptote is step 4. This is where you're trying to match the scenario. There's 3 to choose from, and you find it by finding the largest exponent up top. That's a 2. Largest exponent in the denominator. That's another 2. Since both numbers are the same, that's scenario 2. Now you don't really have to write any of that right there, but you do need to find the coefficients of the top, the lead coefficients of the top and the bottom. So up top I see a 3, and on the bottom I see a 1, which means you have a horizontal asymptote at 3. So find 3 on the y-axis and draw a sideways dashed line. And we're almost done with this problem. Step 5, make a table. I would go to the calculator and find some coordinates. So I'm going to shade where we want to be looking. We want coordinates. I picked 2 coordinates in each region. So I picked 2 coordinates in this region. So maybe -4 and -3. Let me actually back up. 2 coordinates in this region, maybe -1 and +1. And then 2 coordinates in this region, because you're going to have 3 parts to this graph. So I'm going to pick -4, -3 for that left region, -1, +1 for the middle region, and +3 and 4 for that right region. You go to the calculator and you type it in. And sure enough, we have 3 different parts. Control T, that'll tell us our values. So we want 4, 5.4, -1, -1, 5.4, and 4. make those coordinates. And you're about done. All right, I wrote one more problem. This is the end of the notes, but you do have a blank page on the back. Let's do another example. I wanted to show you one where it's not very traditional, or maybe it's more advanced. I don't know how we should say, because the previous one, that's very basic. That's what you typically see. It's not weird, but this one right here is kind of weird. It actually looks very similar because of that x squared minus 4, but I hope you notice right away that things cancel. And that's something you really need to be aware of. That's why it's really nice to be good at factoring, because this thing actually simplifies down to 1 over x plus 2. And that changes things in regards to vertical asymptote, x-intercept, things like that. So step 1, y-intercept. No real change there. You can plug into the blue thing or the red thing and you'll get the same result. I'm going to plug into the blue one. And we end up with 1/2 or 0.5. So when we graph that's kind of sideways. A little better. I'm going to make 1 dash up. And make a dot at 0.5. There's our y-intercept. X-intercept is where things get a little bit different. So you're supposed to set the numerator equal to 0. And if you set the blue one equal to 0, you get 2. But look over here. There's a 1 there. If I set that equal to 0, I get a false statement. That's a sign that something weird is going on at 2. We don't have an x-intercept there, and you'll see why in a second. So I'm going to circle that spot because I know something's going on. Let's move on to step 3. Vertical asymptotes, and we'll see what's going on at this point. So we take the denominator and set it equal to 0. Factor it. And we already know what happens because we did it up top. So because, let me change colors. Because this canceled right there, there's a hole in the graph at 2, which is why we have a circle on that spot on the x-axis. Because look, that was supposed to be our x-intercept, but yet it got canceled out. So it's kind of weird. We do have a vertical asymptote right there. So we can make that dashed line. Let's make a dashed line at -2. And then horizontal asymptote, that's pretty straightforward. Horizontal, that's pretty straightforward. Nothing weird on that. It appears like you get 2 different answers depending on if you look at the blue or the red at the top. But really, you get the same. If you look at the blue, the largest exponent is 1, the largest exponent is 2, and n is less than m. If you look at the red one, top right up there, the largest exponent is 0, largest exponent is 1, n is still smaller than m. That is scenario 1. And we know we have a horizontal asymptote at 0, which is another reason why you have a hole in the graph at that spot. It's kind of hard to keep all this in check. All right, almost done. Let's make a table. Pick a few values. I'm going to pick -4, -3, because those are left of the vertical asymptote. I'm going to pick -1 and +1 because those are right of the vertical asymptote, and type it into the calculator. So in the calculator, we have a fraction, x minus 2, x squared minus 4. And when you see the table, you'll see something weird is going on at 2 right here. But if you go to -4, it's -0.5 down. -3 is -1 down. -1 is 1 up. And 1 is 0.33 repeating. So -0.5, -1, +1, and 0.33. Whoops. Those are down. Losing my mind. So on the left side, it's pretty easy. We get a graph that does something like this. On the right side, we have a hole in the graph, so don't forget to take into account that. So we have a hole right there, and then it continues on. Let me try that line again. And that's it. All right, see y'all later. Bye.